this would be for anybody looking to build something on a blockchain, including enterprises, because this is the same answer, is Quai is built to guarantee that, roughly speaking, we can do a transaction for a penny today, we can do a transaction for a penny tomorrow, and we can do a transaction for a penny in 10 years. That is how this is constructed. So if you want to build an application that's benefiting from blockchain and have a guarantee availability over a long time horizon, this is the only way to do it. And then on top of that, it's still decentralized and censorship resistant. So once Quai is out and the network is up and it's running, there's not going to be like a Quai 2.0. We're not going to like rug pull on proof of work and go to proof of stake and change the monetary policy or inflation rate. Algorithmically determined, algorithmically set, the promises of Bitcoin, the guarantees of price of transaction and throughput.
Welcome to Mission DeFi with Brad Nickel, where we explore projects in decentralized finance that are innovating and driving our mission of financial freedom forward. Thank you for listening. If you like what you hear, please subscribe, rate, and review Mission DeFi and spread the word by posting a tweet to the show. All opinions expressed by Brad Nickel or his guests are their opinions and do not reflect the opinions of Black Knox, Material Indicators, or any other affiliated organizations. You should not treat any opinion expressed by Brad Nickel or his guests as an inducement to make a particular investment, follow a particular strategy, or become involved with any project. A project being featured on the show is not an endorsement of that project in any way. This podcast is for informational purposes only. Now, here's Mission DeFi with Brad Nickel.
I have Dr. K, one of the founders of Quai Network, which I've just become familiar with over the last couple of weeks. And they are building what sounds to be like a pretty innovative blockchain, trying to solve the trilemma that all blockchains have faced. And I'm going to let Dr. K first start by giving us like a 2-minute overview of what the Quai Network is. And then we're going to climb into his background and how he got into this, and then how Quai Network came about, and hear more details about why they're building what they're building. Does that sound good, Dr. K?
Sounds great. Thanks for having me, Brad. So to jump into Quai Network is a hierarchy of merge mined blockchains that will allow us to scale a blockchain to basically be able to accommodate all of human-based commerce. And people have been shooting for, scaling, and people have been describing sort of the limitations of the blockchain. We think we have unique insights into what the real sort of engineering boundary frontiers are, which are slightly different from the trilemma. And because of that, we think we have a solution that allows us to scale without really compromising decentralization or the security guarantees of a system like Bitcoin. So we use a couple novel mechanisms to do this: proof of work 2.0, hierarchical merge mining, trustless bridging amongst a multi-chain, multi-thread environment. But all of those things wrap up into allowing us to dynamically shard and scale so that we can easily do 50, 100,000 TPS.
I think that it sounds incredibly ambitious. But I assume that there's a reason for you guys to be so optimistic about what you're building and why you think you've solved this problem. But first, can you kind of give us your background and how you got to here, right? Which I got to believe is a pretty interesting story to be taking on this problem at this point. So give us a little bit of the background about you and how you got here, and then how Quai Network came about, if you could.
Yeah, so my background, I have an undergraduate degree in engineering. I went to work for a few years in hybrid electric vehicles. And after about 4 years of that, I decided to go back to grad school. I got a doctorate in engineering. And when I was in grad school, basically the first year I was in grad school is when I really sort of dove into Bitcoin. That was back in 2012. And then throughout grad school, I was looking at this thinking, wow, this is revolutionary technology. Sort of like, how can I participate, in a meaningful way? and counterbalancing that with wanting to finish my doctorate. So in 2015, I had half a mind to quit grad school and just try to figure it out. But in 2015, it was hard to find legitimate employment in the space. So in 2017, I ended up graduating. I went to work for Consensus consulting company to work on Ethereum. So was basically focused on energy related applications of blockchain at that point. I did a spin out called Grid Plus, which really was looking at two things. One was how can we use crypto in an actual transactive way? And the premise was if you could couple real-time energy payments to a real-time energy market, using crypto, you can make the markets more efficient. And part of the other thing that Grid Plus was focused on achieving to do that was simplifying custodianship and doing that through something called the Lattice One hardware wallet. So, I was the designer, engineer, and builder that saw it from nascent idea all the way through to production.
Wow.
And people can go buy the Lattice One. So one of the cool parts that I really like about it is something called a safeguard. So it's a chip-based card, and every Lattice has a card slot. So you can have one hardware device and have many seeds that are
Nice.
cryptographically enforced on a chip. So it abstracts crypto like a nice little card. So I don't have to think about a seed phrase. I just how a debit card works. I've basically made it look like a debit card now.
That's brilliant. I had no clue, and solves a big problem.
Yeah.
That's
So
fantastic.
that's one of the things I did at Grid Plus. And sometime in the interim, I was just thinking about the other issues around scaling that you sort of need to solve to get crypto. Because if you have to step back and say, what are the two problems with crypto? It's custodianship at its core, and it is scalability. Like those are the two issues sort of holding the industry back, right? So that's really where my mind has been focused since I've started. And at some point I came up with this idea of how to scale using hierarchical merge mining called block reduce. And so last year, well, let's roll back. So I came up with this idea of block reduce, and I shared it with a professor of engineering at UT, and he's basically like, "This is a great idea. We should do it. Like, let's get some grad students. Let's start doing a research project." So we did this research project. We got an NSF grant in late 2019, and then we had grad students kind of working under that grant to do a proof of concept implementation of the block reduce concept. And then one of the students, who was actually an undergrad that was working with the group, ended up deciding to quit Apple, and then he took on the lead role of raising money to further the project. So he managed to secure money from Polychain Capital, and then I decided to come over full time. And we've been for the last year, trying to bring to market Quai network, which is an implementation of block reduce. So that's kind of the story of the background of how we got here, I guess.
Let me ask a couple of questions. So you started off like everybody on the Bitcoin side of things. Was that the transition to Ethereum? Was that really a consensus? Was that something that was obvious to you, that it made sense to be working on Ethereum, just the whole world computer and capabilities of it, that, when you moved? Or was that something where you were kind of like, well, I've looked at Bitcoin all these years, but was it something in your mind that was better, or was it something that was just different for you?
So I'm very much an engineer, and I try to pride myself on being flexible in my opinions, given new sets of information. So if I have a conclusion, it's ideologically based and the information set hasn't changed, I'll be incredibly stubborn. But when new information comes to bear, I like to think that I have flexibility to imbibe that information and not worry about my previous conclusions, right? So Bitcoin's a great idea. There's obviously limitations to Bitcoin. And, when Vitalik came up with Ethereum, he was like, Bitcoin's really hard to develop any secondary applications on. That was effectively the premise, right?
Right.
Because he was working early with things like colored coins and trying to imbue secondary, characteristics and use cases, but it was very difficult to do. So there was clearly a market opening, and there was a value proposition to it. So obviously Ethereum was, a good second sort of attempt at things that added features and functionality that allowed DeFi to flourish, which was really much more difficult, if not impossible, to do with Bitcoin as a base, right? So
Sure.
so there's a value to that. At the same time, there's also issues with that, right? So nothing is free in this world, but MEV exists in both Bitcoin and Ethereum, but your MEV consequences in Ethereum are much higher. And maybe that's just because of the nature of the relative development, especially considering like ordinals. And I don't know if you've seen that controversy that's been bubbling
I
up in
have.
the,
I
the
have. I
Bitcoin
just
space,
discussed it on the show today. Yeah.
which is really funny to me.
It is. It's hilarious.
Yeah, so it's pretty funny. So I'm open minded with new technologies and like new ideas and new advancements. I think the things that I am reticent to are the compromising of the ideals that Coin sort of introduced, which is the concept of censorship-less, decentralized, uncontrollable, like opt-in, free and fair money, right?
Right.
So everything that I'm focused on is trying to create systems which better imbue those characteristics, right? So if you think about like the two problems, custodianship and scalability, in my mind, those very much play into decentralization and censorship resistance, right? So those are kind of like the core tenets that I'm always looking for new technologies and trying to develop new technologies to make those things better.
Makes
So
sense. All
I'm
right.
neither Bitcoin maxi, I'm not an Ethereum maxi. I am propose me an idea and let's talk about it maxi.
Nice. Love it. Yeah. I consider myself an anti-maximalist. So, and I feel like innovations like what you're doing at Quai are exactly what this world needs, right? Everything we do to step outside of what we have and break it, fix it, improve upon it, whatever, drives everyone else to do better. It's just kind of the nature of the beast in tech. So,
Yeah, well, I think that's like one of the amazing things that happens in crypto too, is crypto is a manifestation of an anti-fragile system, right? So
right.
kind of once we got over the hurdle of the idea of how to objectively coordinate at a mass scale, everybody's just trying to figure out the best way to do it now.
Yep.
But because it's non-monopolistic, it's an evolving environment, and when you shock the thing, it causes the environment to react and become more robust. So, sort of every controversy or you know exchange collapse or regulation or crackdown is actually just causing the whole thing to become more robust and stronger. Um, and so, barring that from the seam, I think that is the definition of an anti-fragile system,
Nice.
which is pretty cool to see.
So when you took the idea to the professor at UT, University of Texas, for those not here, not Tennessee, was it TU? No, it's UT at Tennessee, isn't it? Volunteer.
Yeah, I think that's right. Yeah, so
Yeah. All right.
UT Austin.
UT Austin, and having been raised an Oklahoma Sooners fan, it's a little tough, but Austin's a great city, so we'll let that go. When you went to this professor with this idea, what was this in your mind trying to did you in your mind think I need to come up with a better blockchain, or was you in your mind I just want to solve this technical issue, this performance issue, and then we'll figure out how it can apply?
Yeah, so I was absolutely thinking about it from a technical realm. It wasn't how do we make a new blockchain, it was how do we technically solve the problem. And I actually proposed early versions of this to people like Carl Flourish and trying to get them to do it in Ethereum, but they were so far along the proof of stake concept that I, couldn't make inroads there. But if
Gotcha.
I could have sold it to them, I would be here.
Gotcha. Gotcha. All right. All right. So let's do this. Let's go back to the kind of summary of what you're doing to try to solve the biggest problems we face in this space. And let's walk through it at a simple level and then kind of climb into how it functions, if you don't mind, if that sounds good to you.
Yeah. Okay. So Quai network is a hierarchy of merge mined blockchains. They're linked together through what we call proof of work 2.0. which allows composable cross-chain transactions established trustlessly, and it also allows the hierarchy to dynamically shard and scale.
Okay.
So
Let's
level,
break down
yeah,
merge mind for most folks.
yeah, great. So merge mining actually is a super OG thing. So I want to say even Satoshi talked about this
Wow.
in like 2010 or 11 before he disappeared. So if you go back on Bitcoin Talk, he actually proposed the concept of using merge mining to create subchains of Bitcoin. So it's like a very old concept. And the first sort of use of it was Namecoin. So Namecoin came up with this idea. They were kind of the original concept of trying to do a decentralized DNS project. And the issue is when you create a secondary chain, you're still trying to get the property of immutability. And when we talk about proof of work, the property is economically derived. So if I want immutability, my immutability is really only as good as the cost of creating an attack on that immutability, which then goes back to how much resource was disposed in making something immutable, i.e., how much work. So when you have something like Namecoin, where people don't want to have to sit and expend resources all the time to secure a DNS record, the question becomes how do you create an economic sort of token mechanism that makes that make sense in a long-term sustainable way? And the rational answer that people came up with is you don't. So what they do is they borrow work from Bitcoin. So effectively how Namecoin works is you create a Namecoin header, which is valid in Namecoin. But Namecoin also recognizes Bitcoin headers. And Bitcoin headers have an extra data field. So if you construct a Bitcoin header and you then take a Namecoin header and the hash of that header and put it in an extra data field, and then that becomes a valid Bitcoin block, Namecoin recognizes that as a valid block. So Namecoin is essentially getting linked into Bitcoin. And all we have to do at that point is incentivize the miners enough to include the Namecoin header in the extra data field of the Bitcoin block. So that was
Got it.
the original concept of merge mining. So then every time a Namecoin block is found with a Bitcoin block, to roll that back or sort of create an attack on the record, you would then have to overcome the work of the Bitcoin blockchain, not just the work that's directly incentivized on the Namecoin chain.
Very nice. Okay, cool. All right. And when and this applies, I'm assuming this applies in Quai to the fact that there are multiple chains involved here, and are they sharing the mining function amongst the chains in a explain it to me like a fifth grader level. Is that conceptually
Yeah,
the
so
application of
so
it?
we've taken sort of that one chain with an alternate chain referencing the first chain. The first chain doesn't actually know about the second chain. And that's
Okay.
sort of one of the things that makes merge mining much more powerful. So in the example of Bitcoin and Namecoin, because Bitcoin doesn't know about Namecoin, if
Right.
something happens in Namecoin, Bitcoin doesn't care.
Right.
So if there's like a bad transition in Namecoin, but it still gets referenced into Bitcoin, that's Namecoin's problem. Bitcoin doesn't care. So
Got it.
that creates a loosely coupled system. So it allows the immutability to advance, but the Bitcoiners aren't actually guaranteeing what's going on in Namecoin because they have no real responsibility for it.
Sure.
So in Quai, the way that you closely couple those things is you say you do care, and that if your Bitcoin and your name coin gets screwed up, that's no longer a valid block in Bitcoin either, right? So
Got it.
now if we create a closely coupled protocol, you can enhance what that is beyond just creating an immutable reference for the subordinate blockchain, but you're actually creating a cross-chain protocol that's validating each other, right? So
Nice.
the protocols say the same in every scenario. So specifically in Quai, then we have a hierarchy. So it's a pyramid shaped thing. We have a prime blockchain, we have region blockchains, and we have zone blockchains. And if you want to mine in Quai, you have to mine at least a slice. So you have to mine prime, you get to pick a region, and then you have to pick a zone under that region. but miners get to pick which slice they operate in and if they want to operate in multiple slices. But to produce valid headers, you have to be producing in three contexts. And any block in any context in that hierarchy, if you find a block and it's valid in prime, but it's also referencing a region and zone, if the region block or a zone block is invalid, that's not a valid prime block. So all your peers will then reject it. So that's how we get a closely coupled system. I'll stop there and let you ask your follow-up.
No, that's great. And so real quickly, this is not directly relevant to what we're on right now, but from a miner perspective, is the act of mining as similar to what we know of proof of work mining now for the miners that would be joining the network to be miners?
Yeah, so it's very similar, except that there's a new set of incentives. So from a miner's perspective, at the very simple part of your answer, Stratum proxy, like get work shares, grind, right?
Right.
However, there's a very strong incentive for miners to figure out how to run nodes in network optimized ways.
Hmm.
So because of how we're doing the architecture, the miners are incentivized to self-select a slice, which does two things. One, they want to find one that is giving them the highest reward of Quai per hash. And then two, they want to find the lowest latent set of peers as to minimize their uncle rate. And the sort of multiplication of those two factors is how they should make a choice of where to mine. So when I say lowest latent set of peers in this hierarchy, we've actually created an incentive for them to self-optimize the network. So they're
That's
trying to
cool.
propagate data in the most efficient ways possible.
That's awesome. And so their methodology is, this is going to sound too simple, but is the optimization is meant to fill the gaps to also improve do the miners, I mean, the miners aren't like locked into any one slice, right? Or they can automatically shift from one thing to another.
It's
Do you understand what I'm
self-organized.
asking?
Yeah, it's
Yeah.
self-organizing. So as a miner, I get to pick where I am. What will ultimately happen is you'll get emergent order out of chaos because something
Right.
is slightly perturbed. So you'll end up getting groupings which are roughly topologically or geographically based. So you could say very generally, region one may end up being the Americas, region two, maybe Europe and Africa, and then region three, maybe Asia. So that's incentivized, and they're not hard boundaries and they're not defined by anybody. It's just optimize yourself. And
Right.
that will emerge from that question.
Yeah, okay. That makes sense. And then in terms of multiple chains, the multiple chains serve a purpose in improving performance, I would assume. Is this something that is defined in advance how many chains there will be? Is this something that can be leveraged by people to build, I'm in my head thinking of things like subnets at Avalanche or whatever.
Yeah.
And
Yeah.
I realize it's not part of the same model, but is that the same? Is there a use for someone to have a chain in Quai, or is there going to be a set number of them that are based on some algorithm that get formed because it's all based on performance parameters?
Okay. So there's like three questions to unravel.
Sorry about that.
No, yeah. Let me just see if I can make sure I remember all of them. So the first question at the high level is there's a fixed number of chains in Quai. So there's this
Okay.
homogeneous set of chains that is fixed to start out with.
Okay.
But if demand increases and the chains measure that through uncle rates, the chain will algorithmically create new additions to the hierarchy. So it can dynamically increase its width based off of sustained demand.
Got it.
So we start out kind of in this 3x3 structure. There's 13 chains, 3 regions, 3 zones in each region, but that's just the starting point. So if you have sustained demand and you're, say, bumping up against a 10% uncle rate in your zones for a long enough period of time, it'll be like, boop, and now you have 4 regions and 4 zones. And you can do that effectively indefinitely. There's a trade-off to that. We can circle back to that in a second. I think I want to answer the question about the alternate chains and the like someone creating a chain. So the value of Quai Network is that we have this sort of layer one now that has this homogeneous scaled set. right? And to do that, all of those chains, like our Quai network, they can all emit Quai as part of the monetary policy. They're enforcing everybody else, like for a prime block to append, it's respecting the zone that it's referencing, so on and so forth. But there's also the ability to create a heterogeneous set. So just like Namecoin could mine into Bitcoin, you could actually build parachains into Quai, wherein
Oh,
they could effectively do the same thing and try to incentivize miners to create references using an extra data field or however they want to do it, and then create smart contract entry and exit things to create trustless bridging between said parachain. And the more they can incentivize, the greater their liveliness would be in that context. So every chain has a very simple way to add a link, and that link can be market competitively consumed by anyone that's trying to create a parachain.
awesome. The I would assume that the user experience here is not one of, well, maybe it is. I shouldn't assume. Is the user experience one of multiple chains, or is the user experience just one of Quai network?
It's our from it depends on the user, but our goal is to make it look like one chain for most people most of the time. If you are sort of a very power user and you're engaged in a variety of either geographically segmented or economically segmented activities, you may find that your awareness of the hierarchy will cause you to be able to save gas fees. But for most users, most of the time, using wallets that we can put together, they'll effectively adapt to that. And it should be largely transparent from a user's point of view. So our goal is to make it so you don't have to see anything. If you do see something, we do address sharding. So depending on where you're interacting, you need to use different address space.
Right.
And that allows us to like easily sort of handle the state trees without colliding them. But in terms of like a send, even if you're aware of the shards, you're still just doing a send. It's just going to take that send a little longer to get there, and it's going to cost you a little bit more money. So even if you're aware of all of the complexity, the net impact on the user is just if you have to go cross shard, it's going to take a little bit longer and just cost a little bit more.
Got it. Okay. All right. So you started research on this 4 years ago, essentially, or maybe three and a half, something like that. And how long have you been actively when did you raise from Polychain?
So we raised beginning of last year. So we're almost 12 months in after the raise.
And was that when active development started on Quai?
So we were doing it kind of like as a research project.
Right.
I was doing it in my spare time. I had some students doing it full time, and we were just trying to see if it would work. And some of the ideas of how to do it obviously got fleshed out, and understanding what the limitations of the idea were, came to bear. So we certainly learned a bunch doing that. In terms of the code base itself, we started actively developing like this implementation of the code base after the polychain raise. And even our first effort, we actually scrapped after 3 months and restarted.
Wow.
So yeah, so this is technically like the third iteration of some form of this.
Holy crap.
Yeah. It's not the easiest problem in the world to solve, let me tell you. And the
Yeah.
subtlety of the code is, yeah, it's something, man.
Well,
Because
it
like
sounds complex to tell. I gotta tell you, just from that's why that question came into my head about the user experience, because what you're building is the dynamic interactive nature of this thing to me sounds amazing to pull off, but it sounds really difficult to make function.
so here's the crazy part about this, and this is I think one of my metrics for like good ideas. And an idea is truly good when you start to see it collapse into simple. So you take something that's like
Nice.
seemingly complex,
I
and then
like
it just
that.
like eventually becomes just this like super super simple thing. And so it took us like 3 iterations, the third code base and all of this work, but like our core consensus code is 600 lines.
Holy crap.
Mhm.
Wow. Wow.
Yeah.
That
Well,
did
and that's
collapse.
that's with helpers too. That's like
Wow.
with helpers and methods and Yeah, no, I mean, that's core consensus is like 600 lines of code. Now, there's a ton of subtlety in those 600 lines of code because
Sure.
we probably wrote 10,000 lines and deleted and like wrote again and deleted and wrote again and deleted and wrote again. So we really understood the problem. And then when you really understand it, it collapses to 600 lines of code and it does the job of coordinating this hierarchy of change using proof of work.
That's so
So
cool.
yeah, well, and that's where I think like ideas like really show their power is in the idea. Once you get that collapse of simplicity, you know that that solution was like correct. If you try to manifest something and it starts building, 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 just gets more and more
Yeah.
complex, you probably didn't actually find the global minima. You're stuck on a local bound and you just don't know it. And like that's why this thing keeps blowing up. Right. And you know, that I think is one of the issues that many people have fallen into with how do you coordinate, how do you scale sets. They like start with the obvious, right? And then they like try to make a step of expansion. And then they're like, oh, and we need validators and we need watchtowers and we need to like make it modular and we need to do collections and proposals and like, you know, and we need to come up with pseudo random time algorithms to coordinate and all of this stuff, right? So like you can see just from the outcome of the problem, all I have to do is I have 600 lines of code and you have to go mine this thing. That's it. That's like the
Yeah.
whole thing at its
That's
outcome.
beautiful.
But if you compare that to anybody else's, you know, proposal or solutions, like they're much more complex. They're much more, you know, moving pieces that are all trying to coordinate together. And the fact that this just condenses to 600 line of code just tells you how powerful it is as an idea.
That's I so love that model. I've been working in tech for 26 years. 95% of the projects I've involved in have been the opposite. And that's a really, I mean, that's an awesome way to think about developing something like this. That's fascinating. I'm so going to use that. That's beautiful. That's
Yeah.
really
So
cool. And it's really cool that you get to see it in action. I mean,
yeah,
you're living it.
elegant simplicity. I'll tell you, I think there's only 3 people in the world at this point that can actually appreciate the amount of subtle complexity in those 600 lines of code. Like you could read it and you could be like, oh yeah, I generally get how this works. But you could probably spend the next year actually figuring out how it really works.
Yeah, yeah, yeah. Right. Oh, that's amazing. That's really cool. How many people do you have on the team right now?
So in Austin, you know, we have an office space. We have about 20 people full
Oh, wow.
time. And then we have probably another half dozen scattered about the world, and we're still growing. So in terms of, you know, developers, you know, probably half the team is our engineers.
Nice. Nice. And this is kind of silly off question, but when you guys were throwing out code the first 3 times, or was that a frustrating moment, or did you realize, was it because you realized something better, simpler was in front of you each of those times?
So this is like a really, really, really weird technical problem because most technical problems have many paths that get you to where you want to go. And like some are better
Sure.
than others. Some go over the hills, some go through the valleys, but like you can get to the point. This was not that. There's like one path that works and there's like no other paths. So like
Wow.
what ended up happening is you're trying to get to the summit of this mountain and you'll get depressingly close, right? Depressingly close. So you'll be like, okay, you know, I've been like struggling to coordinate these blockchains. We're like producing pending headers, we're mining, we're making these choices. And I can get it to run in a multi-computer environment with multiple miners for 1,000 prime blocks. So maybe, you know, 20,000 zone blocks. And you're like, sweet, we're like right there. Nope.
Uh,
You're not 10% of the way there. You did the first 10% and you need to backtrack 80.
oh,
And then the crazy part about it is that happened like 8 times.
oh my God, man.
Yeah, so, like, I was having, like, fever dreams trying to figure this problem out because, you know, you make progress and then you're, like, punching a corner, and no matter how much code you make or, like, how many edge conditions you think you're just, you know, adding one more condition to, you can't punch through the corner. And until you realize that you're in a corner and what that corner really is, like, you can't take the next step. And so like that
Right.
literally happened in the manifestation of the code that we had after the third attempt. It took us like 9 times to get to the top of the mountain.
Wow.
Yeah.
Did you always
We, we
I'm
were
I'm
always
sorry for these.
we were
Go
always
ahead.
pointing north, right? So like once we figured out where the
That was
peak
my
was,
question.
like we
Yeah.
were always pointing in the right direction, the peak. We just were taking the wrong road and like they were all branching off just like a little bit higher. So like we were really going to the right path, but like how much you had to backtrack to like figure out that
Uh,
you took the wrong turn. Never seen it before in my life.
so it was never a moment of this isn't possible. You were confident that it was there and that
We
you
we
could
we
get
were
through it if you
confident.
could stick with it.
There was maybe 2 of those times that at least for a few minutes, I was like, "Shit." There there
Oh
was
my
at
god,
least
dude,
a
all
couple
those
minutes,
hours of work.
years of thinking about it. There was a couple times I was like, "Oh, no. Is
That's
this the
nuts.
problem?" But we ended up solving them, so we made it to what we
Wow.
think the peak is.
That's awesome. And so,
Yeah.
well, yeah, I'll get to those questions later. What Where are you now in terms of Quai? And I'm not asking for drop dead dates or anything like that. Just kind of, where is the project at this point?
So we're currently testing for our third test net. So like we're testing the front end tools, we're putting the back, the client itself through different conditions. We're testing partitioning, partition tolerance. We're testing, syncing. We're testing, fork resolution. Right. So like we think we have all the things worked out. It's just sort of these edge problems to make it a robust user experience for the different user stories, right? So if you're a miner, if you're a node operator, if you're a developer, we're working through the bugs at this point. This is kind of where we are. So last Friday, the sort of core team went out and got beers, and we said we finally we finally got it. Maybe it was the
Nice.
Friday before, but very recently we were like, we got it now. Right.
That's
We don't think
awesome.
there's any more backtracks. Everything here is just wanting flies. So that's where we are. We're feeling pretty good about it. And, you know, I would
Do you
expect
think
us to
this
be able to announce testnet this month.
do you think this time next year you'll have users on the network, or are we further away?
Oh, yeah, no, we're definitely gonna be able to go live this year.
Oh wow, nice. That's exciting.
Yeah.
What do you the
So,
folks at what do your buddies at Consensus think?
well, the problem with Ethereans is they've become maxis, right?
Yeah, it is the
So
problem. It's painful.
yeah, I mean, it's like hilarious to see because you're like old school Bitcoin. You're like, great, this is a new idea. Like, throw off the man. We're gonna change the world. Ideas are the power. And then suddenly, I don't know, something happened at some point, and then everyone started talking about like the orthodoxy of Bitcoin, and it's
Yeah,
the only digitally scarce asset. It's digital gold, and all of these like ridiculously you know, arguable positions, and you're just like, Jesus, where'd this come
yeah.
from? And then you're like, okay, these new Ethereans, neon cats and rainbows and unicorns, like they're the rebels now, and you're doing the thing, and now they're turning into hard lighters. It's just, oh my God. It's just like so
Well,
sad to see, right? Because it's like the
yeah.
rebels are always turning into the orthodoxy, and then they're like the enforcers of it too. So like the same
Oh,
people
it's
that are say, let's do the new thing, let's change the thing, it's gonna be like all great, better, and we're gonna do it together. At some point, retrench into these positions and like, this is it. This is the only thing in the world. Anyone who else says it's different is, a
it's true.
heretic. Burn
It's a
them.
belief system. It goes from being a technology and tool to a belief system. And when that happens, it's really difficult for people to let go of that and open their eyes to what else is possible. It's pitiful.
Yeah, I mean, I get it. Like it's human nature, right?
Sure.
It's that sunk cost fallacy, and it's tying up ego in work. I
Yep.
100% am like super sympathetic to it.
Sure.
But at the same time, like once you fall into that trap, you can no longer develop or advance as a human. So you always have to be hyper cognizant of how ego is playing into your assessments of new information. And
Right.
right, I would like to think that if somebody told me today that they have a better idea than Quai, I'd be like, sweet, let's do it. And just, you know,
Yeah.
now the thing is, from my understanding of the problem, I think Quai heuristically approaches what is physically possible. Ergo, I don't think somebody within the bounds of physics could tell me a better solution.
Oh,
But
nice.
if they did, I'd listen to it.
Yeah, yeah. Now, see, but that's yeah. I'm not gonna. We don't need to sit here and bash maximalism anymore. But I totally agree with you. And it's funny because it's true of every part of life, and that's just everything from tech to sports to God to politics. It's one of our great human weaknesses. So it's just too bad to see it in this space because if any space shouldn't have it, it should
That
be this space.
that's the disappointing part about it, right?
Yeah,
Is
yeah,
exactly that, right? You
yeah.
expect it everywhere else. You don't expect it to entrench from the rebels, right? Like, it just doesn't make
Exactly. Exactly. Is this doing I thought I saw something about EVM compatibility. What is there as a developer language? Is it EVM compatible? What how do you get protocols deployed on Quai?
Yeah, so Quai is EVM compatible. Right now, the implementation of Quai that we're going to test network with actually is the EVM. However, in the next test net, we're probably going to switch that out to a WASM
Aha.
VM. That being said, we're going to maintain EVM compatibility, right? Because when most people talk about EVM compatibility, what they're really saying is, can I compile Solidity and deploy it on
Yeah,
the block? And you can do that with any WASM VM. So we will
right.
maintain EVM compatibility, but we will trade it for a more performant, more supportive, more extensible virtual machine.
Makes sense. That makes total sense. Okay. So kind of this I got to tell you, the concept of launching a blockchain, especially one as ambitious as this, to me sounds a bit overwhelming. And thinking about all the moving parts that have to go into this, all of the things that have to make Quai a success, from miners to node operators to developers, recruitment onto the chain to users. I mean, is this in your role in the organization? Is this something you also are having to deal with, or are you able to be focused on the technology and other people are thinking about kind of all of those issues, or is that something you have to think about all of it?
Yeah, so I definitely have to think about all of those things. I don't have to execute on all of those things,
That's good.
right? My primary focus and role is, figuring out how the technology works and then strategically guiding the other sort of pieces. And there certainly are very important pieces, right? So when we think about money, I believe money derives its value from two things. One is utility, and the second is future expected value. So
Right.
as a technologist, I believe if I took the time, I could probably prove how this concept can maximize utility. I haven't done it, but understanding the space, I believe like we're getting close to that point where it is. Then, so the next piece, and in long-term equilibrium, that's all you need. But long-term equilibrium could take anywhere from a year to 100 years to play out. So obviously, the future expected value piece is always, a piece that needs to take place, right? And that is, how do you get the size of the user base to grow, right? So my utility is impacted by future expected value, because if people don't have, a positive look at that, then the number of people I'm going to be able to transact with is low, right?
Sure.
And you can say, look at how many people have the Nigerian dollar versus the US dollar. Not saying that they both aren't things falling off a cliff, but one's certainly falling at a higher rate than the other, right? So, the number of people that are willing to transact in Nigerian dollars is significantly smaller, which means it has significantly less utility than the US dollar. So, right, half the team is focused on, how do we do ecosystem development? How do we get good projects to want to come build on Quai? How do we draw new developers in? So, that's the marketing effort, the business development effort, and half of the organization does that. Or the other half of the
Right.
organization is figuring out how to get the maximal utility. So it's certainly something we're aware of, and it's something that we do focus on.
Okay. I feel like we kind of I got I got off on tangents here about your experience of building this, but I don't know that we covered kind of all the benefits of Quai to as a new chain. And so I'm wondering if you could kind of go through that for me. We didn't talk, I don't think we
Yeah,
talked
yeah.
about
I
benchmarks
think
and all of
I think
that. So
one we missed because you were asking like three-part questions are subnets. So one of the other benefits. So we've talked about the incentive to get miners to optimize network use and organization simply through wanting to minimize their uncle rate and maximize their return.
right.
The other piece, though, is the subnetting piece. So when we talk about a network and we talk about data propagation in a network, if we want to approximate a network of nodes like Bitcoin as an n by n graph, the number of hops that I have to go through to propagate data in the network is on the order of n log n. So if I have a network of Bitcoin nodes and I say I have 10,000 Bitcoin nodes, I may need to take 7 hops to get data propagation in the network. And
Okay.
when I create a subnet, I get to divide my n by the number of subnets that I have. So in Quai, I can divide that by 9. So if I divide the n by 9, my number turns into like 2.5 or 3. So I've decreased the total of number of hops, but I've also created the incentive for those hops to be very fast. So if we look at something like Bitcoin, it might have an average ping latency against nodes of 100 milliseconds. So I take 7 times 100 milliseconds. It means at the very minimum to get data around the network, I need 700 milliseconds. If I divide that subnet out and I say it's 3 hops, but I've incentivized those people to self-organize, I could be at 10 millisecond ping times. So I'd end up comparing 30 milliseconds to 700 milliseconds. Right there, you get a 25x improvement in your data latency of propagation in the network, which is ultimately the limitation of throughput of any network. Like there's like a hierarchy, but basically what it is the time that I take after I hit consensus to become consistent determines my uncle rate, right?
Right.
So if every Ethereum node, proof of work Ethereum, had all of the transactions that were included in a block prior to that block being found, the only latency then at that point would be for them to get the header and then for them to check the transactions in the header. Right? There's still going to be, okay, I have to do some, IOPS on the drive, whatever, but that would
Right.
be a very short period of time. If they're missing 10% of those transactions, they need to go find them. So they're now inconsistent, right? And the higher the TPS I have, the more likely they're going to be inconsistent. So the worse uncle rate I'm going to expect as the TPS goes up. And you naturally see that as an emergent phenomenon within Ethereum. So when we circle back to what we're really doing at Quai, it goes back to this concept of breaking the trilemma. And I can hop into that if you
Yeah,
want.
yeah, yeah. Definitely want to hop into that.
Okay, so Vitalik proposed the trust 5 years ago, I think.
Right.
And basically he was trying to define the trade-off design space of blockchains. And it's a very hard problem to understand, but he definitely did not create an accurate description of the problem. And it's certainly not an engineering description. It's maybe like a subjective description. And you can understand that it's a subjective description just based off the points that he put in the triangle. Because I can't really assign units. And he didn't
Right.
assign units and he didn't assign measurements. So it's decentralization. How do you measure decentralization? Is that in
Right.
kilowatts? Is that in milliseconds? I don't know. Right? How do we measure security? Right? Throughput we can obviously measure, right? That was the other point of the
Sure.
triangle. So throughput we can say, okay, TPS, or we can say bytes committed to chain or something. But we could
Right.
assign units to TPS. The other ones are some gestaltic amalgamation of many quantities that we kind of understand as a word, but we can't define. So it's clearly
Right.
not a vertex in an engineering boundary.
No.
No. So what the problem really is actually much more closely described by something called cap theorem, which academics came up with in the mid 80s to talk about limitations of databases, distributed databases, and distributed computing systems. And that is a much more apropos frontier when it comes to blockchains, but they miss one additional point. So in the CAP theorem, they basically say that your compromises are between data availability, partition tolerance, and consistency. This is all true. But one of the criticisms of the CAP theorem, even within academics, is there's assumption about the eventuality of these things completing in some indeterminate time or having synchronicity of those in the network. So they're missing like a point, and they've kind of ignored it. And that point that I argue is the fourth point, not in a square, but now a tetrahedron, is what I would call finalization latency, which you could also say is consensus. So what we've done is we've figured out how to decouple consistency and consensus, and we can actually enforce or create a system where we can ensure global consistency prior to consensus. So within the subchains, we're still in a situation where we may be inconsistent at local consensus, or inconsistent at local consensus, but I can always ensure that by the time I get to global consensus, I am globally consistent. So we've inverted that property, and that inversion in the different scope is what allows us to scale to the physically defined limits of the internet and computers that are operating the nodes.
That's amazing. Okay. So really the key here is that you feel like Quai network can scale to the full physical capacity of the internet. Speed-wise.
So I wouldn't say it's going to scale to the capacity of the internet.
I shouldn't say capacity. What it's capable
of the infrastructure.
Yeah, the only limit is the infrastructure of the internet, the capabilities of the bandwidth, the data. Yeah. Okay.
Yeah, that's right.
That's I think that's what I should have started with from the very beginning of this interview. But that's pretty amazing. And you said earlier, if someone comes along with something that takes us beyond that, I'm really open to it. But there really is nothing beyond that.
I don't see
replacing the internet.
Somebody could come up with an alternative system. I don't think it would have a DLT. There probably are systems that can scale better, but they won't involve a DLT. So if the construct involves a DLT, I think that this is where you're physically constrained. The other point that I do want to maybe highlight is how we're doing the sort of trustless bridging, and so how we make this whole thing look like sort of one blockchain rather than an aggregation of many.
Yeah. That'd be great.
Which I think is an important technical concept. So when we talk about having multiple blockchains or multiple threads of blockchains in this hierarchy, we call it a braid. And the reason we call it a braid is because when you find a block which is valid in multiple contexts, we call that a coincident block. And the way that we sort of can enforce that taking place is when you're mining a slice, a zone block has a different target time and a different level of difficulty than a region block than a prime block. So zone blocks will run 10-second sort of Ethereum block times. Region blocks will be 100 seconds. Prime blocks will be closer to Bitcoin block times, which are like 1,000 seconds. So just orders of magnitude as you go up the hierarchy. That means that you're getting actually 30x increases in difficulty targets with each one of the levels in the hierarchy for the 3x3 ontology. So what that means is for every prime block in a zone context, I would expect to find 900 zone blocks between a prime block which references that zone block. But that prime block that I find is a very special block because it's called a coincident block. So it'll be valid in prime, it'll be valid in the region, and it will be valid in zone. So I have a single block that has a single hash that's traceable in 3 different chains. So what I've done is I've just braided that set back together, and I've made it objectively referenceable in every other context.
Nice.
Right? So those stochastic interlinks are actually how you get the data transfer and how we get delayed global consensus. So I can asynchronously advance in the different zone heads, right? And it's only when I get tied back together the transactions that originated in one of these asynchronous tips become referenceable by the other ones, right? So it eventually braids itself back together, and that's how we're getting trustless bridging. So we've taken a very simple concept, proof of work.
Wow.
We've extended into merge mining, which then allows us to trustlessly transfer state over the multiple chains. And the cool part is because I'm respecting the protocol in every context, if I ever get a roll forward in one context, I get a roll forward in all contexts. If I ever get a roll back in a context, I get a roll back in all contexts. So I can create atomic guarantees of head propagation, although the heads are asynchronously advancing.
Wow, that's amazing. Wait, was this part conceptually, was this part of the research you guys were doing from the beginning?
Yeah, I mean, so this all plays into the sort of the original idea, right? So the
Okay.
original idea is, how do I get stateless transfers? How do I make the propagate, like, what are the limits of throughput? And then how do
Right.
I improve upon those limits? And the cool part is the answer to all of the questions is like one thing. So like, how do I trustlessly bridge? How do I optimize data propagation? How do I minimize latencies? It's all the same answer. And that's why it's so
That's
simple.
amazing.
Because I just do proof of work mining on a hierarchical chain, and all questions of what we need to do to scale blockchains get answered. And that's why consensus is 600 lines of code.
That's truly, that brings it all together. That's beautiful. Wow. Okay. If you were at consensus and somebody else was building Quai, what would you how would you, like, at the gut level, attack Quai if you were one of
Oh,
those
you're
maxis?
trying to steel man the alternate argument. So I don't actually have a okay, yeah, okay. So
Okay.
there's good arguments and there's bad arguments. So I think I'll just address the good arguments rather than having to dispel the bad ones.
Waste your time on the bad
Yeah.
ones, which will
Um
still come, but that's okay.
yeah, but let's just focus on the good ones.
Okay.
So we can infinitely scale. But if anybody ever tells you something that they can solve a problem and there's no compromises or consequences, they're absolutely full of crap. If it's
Right.
an engineering problem, if it's a physically constrained problem, like, and they're like, "Oh, we figured out batteries or efficiency or, you know, I don't know, whatever it is, fusion."
Right.
They're always lying to you through a mission. Okay, so I'm not going to lie to you through a mission. I will tell you what the compromise is. So we can
Awesome.
infinitely scale, but what you're giving up is global consensus times.
Right.
So if you do a transaction and it's a single context transaction in a zone, looks like Ethereum, 10-second times, great. You get some degree of finality and settlement. But if I do what I would call a cross coordinate transaction, so something a far cross coordinate. So I'm going to another shard and I'm going to another shard that's far away in the pyramid.
Right.
That will take time. And that
Sure.
time is dictated by the width of the ontology.
Okay.
Okay, so as I increase the number of shards, the time that I'm going to actually be able to re-reference that in the destination increases.
Okay.
This is a fundamental trade-off of sharding a data set that is trying to create consistency and consensus. So I don't think this is a unique problem to Quai. I think this is a
Right.
problem you will always have. And depending on how efficiently you're arriving there, you will be closer to what's physically possible or farther away from it. So that being said, let's do a practical example. In the 9 by, the 3 by 3 system, so we have 9 zones. If I want to send a zone transaction to a close coordinate zone, in the original ontology, that may take 4 minutes before I can re-reference that transaction at the destination,
Okay.
right? But if I want to go far coordinate, I'm going to have to get a prime interlink reference in 2 contexts. Okay. So that could take 9 prime blocks. 9 prime blocks at the 10x increase in time at each level is 9,000 seconds. So that's
Right.
3 hours, right?
Right.
That's your trade-off. And if I double the hierarchy, I'm gonna double that time. So if I have to go
Got it.
from 9 shards to 18 shards, I'm now at 6. 18 to 36, I'm at 12. Or yeah, 12.
Okay.
So that's your trade-off. Now let's put that in context of like what we deal with in a global monetary system currently. We have pseudo instantaneous settlement with credit cards. It's not real, it's because we have these trusted intermediaries that we pay points to that are kind of used all over the place that like settle. So we have instantaneous settlement, but it's not real instantaneous settlement. But let's say I
Correct.
want to do an ACH or I get paid. Those have real settlement times. Like when you see your direct deposit, you don't have instant access to your direct deposit. That may take a day, right?
Right.
That may take 24 hours. If I do a Swift wire internationally, that may take 3 days. It may take a week. So
Yeah.
we already have these multi-context things that have different real times to settlement where I could re-reference the money at the destination. So this compromise like isn't breaking. We might be like, oh, well, in Ethereum, we can do everything in 10 seconds. Well, Ethereum doesn't scale. So great. But if I tell you I can scale to a global commerce and I tell you, okay, maybe it takes you 24 hours when we have to shard to the degree that we can handle 100,000 TPS, that's fine because that's what we already do. And not only is it
Right.
fine, I'm probably doing it more efficiently and better than it's already been done. But if I had to make like an argument against Quai,
That would be it.
that's your real argument. That's your real
I
trade-off.
love it. And that's a great framing of it as well. And as another reference point on current systems, just tell the guys that were trying to sell or buy GameStop stocks that their trading was instantaneous, and they'll probably beg to differ with you. So
Especially if they were on Robinhood.
exactly. Where does the name Quai come from?
So I'm a fluent Chinese speaker, Mandarin.
Nice.
And I is the measure word for like a unit of currency. So if like you're in China and you were to formally say, how much is that? The response would be Quai renminbi, which is 1 unit of the renminbi. So if you had to say like what that is in English, it would be like saying that's $1. Or in, the UK, it'd be like that's 1 quid. So if I say it's 1 Quai, that's kind of the meaning equivalent of it.
Well, even if it was a made up word, it's a great sounding brand name. The fact that it is that makes it all the better.
Yeah. Well, so that's one of the reasons I picked it, because like I was going through all the things, and one of the things that just annoys me to all get out with Ethereum is a theory and then ETH and then Ether. Right? Like all of those are used and all of them are overloaded. And like, guess what? I could just say Quai, and then I can say Quai, and then I can say Quai.
And it covers
That's
them
all you can
all.
say.
I love that.
One
That's
syllable, and it's all the
beautiful.
things.
Is it what else? I mean, I'm sure there's 100 things, but what would you tell a group of founders of who will probably be listening to this, of existing fairly successful protocols about getting engaged and why they should come take a look at Quai?
So what I would say, and this is actually not just for founders of protocols, but this would be for anybody looking to build something on a blockchain, including enterprises, because this is the same answer, is Quai is built to guarantee that, roughly speaking, we can do a transaction for a penny today, we can do a transaction for a penny tomorrow, and we can do a transaction for a penny in 10 years. That is how this is constructed. So if you want to build an application that's benefiting from blockchain and have a guarantee availability over a long time horizon, this is the only way to do it. And then on top of that, it's still decentralized and censorless, censorship resistant. So once Quai is out and the network is up and it's running, there's not going to be like a Quai 2.0. We're not going to like rug pull on proof of work and go to proof of stake and change the monetary policy or inflation rate. Algorithmically determined, algorithmically set, the promises of Bitcoin, the guarantees of price of transaction and throughput.
Love that. We talk about protocols in like liquidity, et cetera, that are just deployed as smart contracts that can never be touched again. I assume there's more that will be done from your team's perspective on Quai after that.
Yeah, absolutely, right. But like, what happens is if a protocol is a decentralized protocol, it ossifies. So
Sure.
we'll have the graciousness of the community to do certain things for a certain period of time. And at some point, that graciousness is going to end, and that's really going to be it. Right. So if you look at Bitcoin, Bitcoin's decentralized because like the last real upgrade was SegWit.
Right.
And that barely got through. That was like a 2-year
Battle.
battle for it to happen. But that tells you something about Bitcoin. Right. So like the goal of Quai is to create a protocol that doesn't change, interestingly enough, that like everybody buys into it, it adds a degree of value. And if you have to ask me like what the protocol is or like what we're trying to do, or how do you build a protocol that can last a long period of time? Let's talk about TCP/IP, right? TCP/IP was developed by the Internet Engineering Task Force. It was largely codified by the late 80s, and the only change we've really made to it is IPv6, right? So like in over 35 years, we
Yeah.
made one change. And like we did it in this backwards compatible way and et cetera, et cetera. But like it hasn't really changed in 35 years. Like that's the base layer. And what is TCP/IP? It is the mechanism as we ubiquitously and instantaneously transfer information around the world. That's what it is. And my goal for Quai is to be the way that you ubiquitously and instantaneously transfer value around the world. Once
Nice.
it's baked, and I hope I'm dead before it changes again.
That's awesome. What a great summary. And you know what? That ties into so much of what you talk about how you're building it and what it can do from a performance perspective, right? Because you don't need to upgrade it if it fulfills the promise of what you are saying it will do. And so at the end of the day, what would you upgrade?
Yeah.
Because the only limit is the physical.
Yeah, no, that's right. And if we wanted to like steel man it, if you want to steel man it, the biggest Achilles heel is the VM for sure. Right now, Wasm is a pretty well put together VM,
Right.
but the VM in the protocol is definitely a compromise.
Okay.
Both in terms of like how you're designing the thing, how you're exposing yourself to MEV, how you're getting computation times. Now, the interesting thing is the company that is doing the development is actually called Dominant Strategies. And Dominant Strategies is a reference to game theory, right? So if you're doing a proof in game theory to make something provable or have a definable outcome, it has to be dominant strategy incentive compatible. So if we look at like what would be the engineering perfect system, I would argue it'd actually be UTXO system, and it would actually be like from a not from a consensus standpoint. Like this is it from a consensus and data propagation and network latency standpoint. But would you have a
Right.
VM in the base layer? The answer is no, you wouldn't. Right. But we know that to go to market and to win the game and to get adoption, kind of have to have a VM right now.
Gotta have it.
So you got to have it. And so, like, that's a compromise we're making. We think it isn't like the end of the world sort of compromise, but if you were talking about like the perfect engineering design, it probably isn't it.
Yeah. Oh, and I don't see any way around that, right? I mean, it y- you're
We
not
don't
going to
either.
have people
And that's why we're
writing for
doing
it. Yeah, I mean, you're not going to have people writing for it. You're not going to have people using it if you don't have it, right?
Yeah.
And it's not like a plug and play module where you're like, oh, let me just swap this out.
Yeah, yeah. I mean, that's the problem. I mean, ultimately, long term, right? So our goal is to be this ubiquitous value transfer protocol. But the interesting thing is, we're actually the first decentralized protocol that's going to be able to make a run at payments, and that's really where we really want to get value to. But the problem is, we still have to, bootstrap in the normal way with ecosystem and DeFi because that's just where we are in history. But the cool part is no other blockchain could actually do it like a Venmo or a Samsung Pay, but we can do all of those things, and we're going to do them really, really well. That's like one of the places that we really want to go is just doing payments, but that's a longer term vision because you can't go to market with payments, right?
Well, I mean, theoretically you could, but yeah, I mean, it's more difficult if you're not
It's
established. So
Yeah, it's more difficult.
I often talk about the fact that, people kind of hope the hopium or that people still have around Solana, right? And I talk about the fact that when you've rebooted a network that many times, you can't overcome that brand problem for, kind of worldwide adoption for use of that chain. It's just not something somebody's going to make a bet on when there are 98 other chains listed on DeFi Llama. But if you've got a chain that actually has the scale that you're talking about for Quai, then I think you become a really interesting proposition for the rest of the world that comes knocking and looking for something to integrate or bet on. So I think, yeah,
Well, to add into that, like it's not just scale, it's reliability at scale. And I actually have an
right.
anecdote that I heard about Solana's BizDev team actually convinced Samsung Pay to integrate Solana at one point. But when they actually went to technically do it, they were falling down so much that Samsung backed out because they said, you guys don't have the reliability for us to put this as a backend payment
There you
system.
go.
This is
Perfect.
untenable. But if you look at proof of work blockchains, Bitcoin has like a 6 sigma uptime. Like when's the last time Bitcoin went down since,
Sure.
forever, right? Like certainly early days, we had like a few forks and like a few inflation bugs and whatever that was. But since then, it's never gone down. Maybe it's locally
Yeah.
gone down, never globally gone down, right? So we believe that we can get Quai to achieve those uptimes, but do it at 100,000 TPS, right? And
Nice.
that's what you need if you're going to convince someone's like Samsung, now that they've been burned by things falling down, to want to address a new blockchain to try to reintegrate with a payment system.
Yeah. No, absolutely. Real quick on biz dev, I often say to founders that marketing is great, but biz dev is everything in terms of scaling and adoption in this world right now. That may change in the future, but is that something you guys are really focused on in terms of building your team out to kind of grow and be able to make those connections? There's a lot to make, but you know what I mean.
Yeah, no, I mean, absolutely, right? So half the team is technical, the other half of the team is marketing and biz dev.
Right.
And we're forming relationships with, small players. We're starting to form relationships with bigger players, right? And we think we're going to be able to, attract some good flagship DEX applications that have had
Nice.
success in other ecosystems. So we're definitely focused on it. We're definitely doing it. And it's just the eating the elephant problem, right? So we're doing
Yeah.
it one bite at a time.
There you go. All right. So real quickly, I asked two questions at the end of every interview with the founder. The first is, and this is kind of odd because I'm usually talking about like protocols on chains, not an entire chain. But over this last 5 years or even previous working at Consensus or whatever, lessons for new founders coming into the space, building in this world from mistakes you've made or just lessons you've learned along the way. What's something you would impart to new founders?
Oh man, it's always lessons, right? I would make sure that you always trust explicitly your founding team. You always have a cap table that you are
Ha,
happy with. So don't make compromises for early funding. And that if you do have some discord within a team, you need to address it sooner than later. That's
yeah.
probably the summary.
Yeah. I bet there's like 3 or 4 good stories behind all of those lessons. That's great. Because they sound very familiar to me. Last question. Somebody, usually somebody, but I also, have had people mention specific projects in the crypto world that's not kind of like Satoshi or Vitalik, that for whom you have a great deal of respect, or maybe even be somebody you'd want to work with at Quai.
Oh, there are a lot of the most interesting sort of group of developers to me are actually like some of the FOSS guys, and they haven't like had a ton of commercial success, but I highly respect them from a technical and cryptographic point of view. Is like Andrew Polstra would be one of them. The Zcash guys, some of the Monero devs like Fluffy Pony, like all of those guys, immense, immense respect for.
Nice.
I don't think that they've had lack of commercial success because they've been too focused on maybe like the technical absolutism in some ways, and I think that's like what has like held them back. But they're geniuses
Nice.
otherwise, right? Like,
Nice. Yeah.
yeah, very very smart guys.
That's hard to
So
deny. Or
Yeah, well,
Impossible to
and
do.
and and so, like, if you have to ask, like, what I think's happened in crypto since 2009, I'd say Bitcoin. I'd probably give Ethereum a shout out, and then I would say ZK Snarks,
Uh-huh.
aka
Sure.
Zcash, and then if you wanna give a shout out to Monero, like, that happened, and then there's Quai, and I think that's the list. So,
Nice.
in the last, like,
Nice.
12 years, there you go. I don't, like, mean to sort of discredit people. I think people have made, meaningful contributions and commercially interesting applications. I just don't think they're technically interesting or novel. So the
Yeah,
technical and interesting novel things, it's a pretty short list.
definitely. Dr. K, this was fantastic, man. I really enjoyed getting to know you. I'm actually pretty excited about what you're doing, and I will definitely be taking a deeper dive and a closer look, and would love to get you when mainnet goes live. Would love to sit down with you again and see where we're headed.
I appreciate you taking the time to dive down the rabbit hole with me, Brad.
Fascinating. Thank you very much.
Thanks.